Okay, so uncertainty. Let's put our phones away, okay? Kira, let's put our phones away. So where do we need uncertainty? Where are we going to see this in real life, right? Industry. Well, I go back. Like I used to work at Kitchen Craft. I worked for them probably about 10 years before I became a teacher. And everywhere we went, everybody had a measuring tape. Pretty much everybody. And wherever you went, whichever department you went to, you always measured everything. Sometimes you just had a measuring tape. Sometimes you had a caliper. A caliper is a fancy digital, one of these, right? To really accurately be able to measure something accurately. It's a caliper, right? So we would have one of these or a measuring tape. And so wherever we went, before we fed anything to a machine, we would make sure, does it meet the criteria, right? We would measure, okay, width, thickness, perfect, feed it through. If it didn't, even after let's say I start my machine, if I messed up on an order, I'd be in big trouble because wood is very expensive. Thousands of dollars down the drain if you mess up. Have you ever heard measure twice, cut once, right? You've heard that. You don't want to cut before you know for sure that it's right. So I would like run my machine, run like 5 pieces and measure. It's like, okay, all 5 are pretty much okay, so let's keep running, right? And depending on what department you were in, the closer you got to the finished product, the more accurate you had to be, the more it mattered. At the beginning, it's like, I'm off by 2-3 millimeters, big deal. Keep going, right? But the further down the process you went, the more accurate you had to be. So we're going to be talking about that, right? Every industry has their own standards. If you go to, what's that, the name escaped me, but if you're making airplane parts, anybody? No. There's a company that makes airplane parts in Winnipeg. And anyways, when you go there, they're going to train you. You have to be super precise, super accurate because all of those parts will go on a plane, right? So they have to meet certain criteria. Every industry is going to train you on that. They're not just going to be like, did you take that in high school, right? So this is just going to be like a basic concept. If you go there, they're going to have their own way of training you to make sure you don't get it wrong because raw materials are very, very expensive. Like metal, wood, any of these primary raw materials, you don't want to mess up, right? Because you could probably get fired if you mess up too badly, right? So you want to make sure you're precise, you're accurate, and you know how to measure something. And always know whether you use one of these, right? If I use a meter stick or whatever I'm using, there's always a chance that you will be off. There's always a chance, right? So can you grab one of each, Angelica, the booklets? One of each. Okay, so Kaden, can I pick on you? You're in woods, right? Yeah. If you cut like 10 pieces, will they always be exactly the same length? No. Why is that? The blade. Why? But even if I have the sharpest blade in the house and it's like perfect, expensive machine, why is it still not going to be the same? Maybe I'm asking too much, I don't know, but maybe you have a reason why. The wood could be warped, or when you're feeding it, you're not feeding it perfectly, right? You're in a little bit of an angle. The blade could vibrate a little bit funny, right? Like it could be off. So you'll never be 100%. So there's always a bit of an uncertainty. But we're pretty accurate, right? But the uncertainty is what we're going to talk about today, right? Which one is more precise? Which one is more precise, this or this? If you could just guess, like, which one would be more precise, would allow you to give a really, really, really accurate measurement? Okay, this one? Anybody else? You'd say this? So if you have to measure this cell phone, can I take your cell phone? Which one would you say would more accurately give you this measurement, this or a ruler? The ruler? No, Raven is saying ruler. I hate to break it to you that this would be more accurate. Because this actually, if this works, it has like up to 3 decimals, like as small as 3 decimals. This one you'd have to, at some point you have to ballpark it, right? You're like, this is about, right? It doesn't go smaller than these units. This one does, okay? Some industries will have like an old school, like you actually have to read it, but most of them are digital these days, right? So a caliper, in this scenario, if you compare these two, this is more precise, okay? Okay, so let's take some notes, and then we will slowly start doing some math. One thing that I need you to know is do not round. Don't round in this unit. Yeah. No, this one. You need an eraser. There's a little bit left. Okay. Do not round in this unit. This is the one unit that I'm going to tell you do not round. So if it's 4 decimals, 5 decimals, it is what it is. Okay. So limits to measurement is, that's what they call it. The province calls it precision measurement. So we're going to talk today about accuracy and precision and uncertainty. Oops. Uncertainty. You're not quite certain. There's a bit of an uncertainty there. We're going to skip the converting rates because right now we're not really going to need it. So skip this. I'll manage without. So go straight to page 81. The reason why I'm thinking is like I forget that not everybody's using imperial these days, like inches, working with inches and stuff, but we'll work with that as we go along. If you have a highlighter, this is where you want to have it ready to go. Page 81, okay? In everyday life, people often use words as precise and accurate to mean the same thing. In mathematics and in trades, however, they mean different things, okay? So accuracy, there it is, refers to the exactness of a measurement, right? To be accurate, the measured value must be as close to the real value, right? You want to be close to the real value. If you measured something accurately, someone should be able to repeat the same measurement. So I will say this, should be able to repeat the same measurement. So if somebody says, hey, this measures 3 meters, somebody else should be able to come and say, let's measure it. Yeah, it's 3 meters, right? If you don't, then it's not accurate. So I will also tell you to box this in. This is just nice and visible, right? Accuracy, how close the measured value is to the true value. Let's add target. True value, target, actual value, they all mean the same thing. And I will add this. If I measured something with my hand span, like let's say I measured the width of my desk here with my hand span, would that be accurate? Would I be able to tell Gino to come and measure with his hand span? Do you think we would get the same? No, we would not get the same, right? So it cannot be repeated. So using your, I will write that down, using your hand span, right, would not be accurate. Comma, since it can't be repeated by another person. Also, sometimes the questions you will be asked is it's regarding improper or careless use of the measuring device, or if the measuring device has been damaged. So I will say that accuracy can be affected by improper use or damaged device. I don't have it on me anymore, but I used to have an aluminum meter stick, and I used to, when I taught grade 9s, for some reason, grade 9s love to bend my, like they just, every time I had a project, by the time I'm done, the ruler would look like this, like a wave, right? So using that ruler to measure anything, now you're off because it's not perfectly straight, right? So that would be a damaged measuring device. I was, over the pandemic, I had to help my son work on a project, and it involved measuring our whole house, the perimeter of the house, rooms, blah, blah, blah. So he had never used a measuring tape before. So he would measure the room. It's like, okay, you stand there, I stand here. And the measuring tape was literally touching the floor in the middle and then back up, right? And he was just recording. He's like, yeah, this is what it is, 100 inches. I'm like, no, no, no. You have to make sure it's straight, right? Like you got to pull on both ends, and then we know the exact distance. So that was improper use of a measuring device, right? If you don't have it straight. If you're into baking, if you have a cup and you put some milk in it, right? 2 cups of milk, 3 cups of flour. If you put flour into that cup and then dump it, what's going to happen to some of that flour? It's going to stay behind, right? And it's actually going to cake up as you add more. And so you're not using that measuring device properly. Some of you are going to be like, big deal, it doesn't affect my recipe, right? But technically, you're not using it properly. So there we go. So that's something you need to watch out for. So I will say this here, write this down. That's why I left this space open here to be accurate. We need a standard unit and scale needs to be appropriate. Example, distance. I'm just going to summarize it. Distance between, if you go to university, you want to learn these tricks because profs don't wait for you, right? Distance between cities. Would you say you would use centimeters, meters, or kilometers? That's right. That would be an appropriate scale, right? So if you had the choice, you want the correct scale for it, or else we would say it's not accurate. You won't be able to be accurate enough. So a standard unit, so standard units, right? Feet, inches, miles, centimeters, cups, and so forth, right? So something legit. You can't say, hey, use your forearm to measure something, or use your, right? Like it wouldn't work. Okay. So that's what I'm looking for something to be accurate. And be sure you're able to explain why something wouldn't be accurate. Either you didn't use it properly or something like that, right? Okay, here we go. So let's explain if the following would give an accurate measure and if the device is appropriate. Okay, so using the length of your forearm, there it is, to measure the length of a picnic table. Okay, you would say not a standard unit Would you say a forearm, though, in terms of scale, it would be appropriate for a picnic table? It's not bad, right? Like a picnic table, the scale isn't ridiculously small or ridiculously large, right? Like a forearm would be appropriate. So we would say appropriate scale. But because you need both of them to be present, therefore not accurate. Not accurate. So the scale is appropriate, but it's not a standard unit and it fails, so it's not accurate. The length of your stride to measure the soccer field, not a standard unit. Would it be an appropriate scale for a soccer field, do you think? I would say so, right? Would you say, like, if you wanted to say, hey, we have a field here, let's measure, you would tell each other, hey, let's walk this many steps this way and this way, right? Like, so scale is good, but it's not using a standard unit. So if I walk on one side and one of you walks on the other side, we're not going to end up in the same spot, right? I'm going to be further than you. So not accurate. Metric stick to measure the distance between two cities, a meter stick, right? Standard unit, all right. Inappropriate scale. So we still say not accurate. And the reason why is because every time you use a meter stick, right, you put it down, you mark it on the ground, and then you slide it forward. Every single time you do that, you're going to be off by a little bit, and that's just going to compound as you get closer to the other city. So you're not going to be as accurate. Using a ruler marked in millimeters to measure the width of the book. Standard unit, check. Scale, would you say it's an appropriate scale to use millimeters to measure the thickness of a book? I would say it's pretty good. You could use centimeters or millimeters, but it is appropriate. So the scale is okay and the unit is okay, therefore accurate. So in math, that's what we look for accuracy. Okay? So as I was saying, in real life, you might use them both interchangeably. Okay. We're good? Okay, we're going to skip the first couple of questions there on 82. I actually will just do this. Just make sure you know that that's supposed to be left out. I just didn't erase it. I should have erased it. So we're going to go where it says halfway through, make sure you circle it or something. I will circle it and then highlight it. Precision and uncertainty. That's what we're going to focus on the most today. Precision and uncertainty. They go hand in hand. They're always together. And here I made a little note to myself. It's coming a little bit later, yeah? Okay, let's focus on the text here first. Like accuracy, precision is related to exactness, but it is determined, it's the limitations of the measuring instrument. For example, can you measure the weight of a pencil with a bathroom scale? You think you would be able to do that? A bathroom scale, you know, like a scale that you step on. like to weigh yourself, would you be able to do it with a pencil on it? Would it move at all? It wouldn't budge. So it's limited. That measuring device is limited. It cannot do light things. So you have to change your measuring device. Could you use a kitchen scale to weigh yourself? No, limited, right? So it's like something is off. All right. So there's a limit to it. For example, if your measuring device is marked off in centimeters, that is as precise as you can measure, right? Let's highlight the marked off. If it's marked off in centimeters, then that's the precision of that measuring device that you're using. Your answer will not be to the nearest center, or will be to the nearest centimeter. A measurement made with a ruler marked in millimeters, if it's marked in millimeters, then the precision will be to the nearest millimeter, and it will be more precise. It'll be more precise. Highlight both of them. Than the ruler marked with centimeters. So the smaller the markings, the more precise it is. Let's highlight this here. Both of these. I will box around them like this. Precision is the smallest unit of measurement on the measuring device being used. And then on the side, uncertainty, I will box that in too with a highlighter. Uncertainty is the margin of error. It's like you have a little window that you can be off by. If otherwise stated, uncertainty, highlight that. Uncertainty is half the precision. And I will underline that with my pencil. I don't break it. Uncertainty is half the precision. Okay? If you're already excited, wait, there's more. I know this is a little bit dry, so I'm trying my best here. So let's write examples now. Not yet, no. Examples. A, let's say I give you 2 1/4, a measurement that says 2 1/4 inches. Make sure you write this down. This is gonna make it a lot easier later on. So 2 1/4 inch, that's a measurement, you're just given that. The second, let's make a gauge here. So make a circle like this. And you're gonna start here, and we're gonna start here, and then we're gonna go 1, 2, 3. Try to space them out equally. So 4 marks in total like that. This is gonna be our empty, our E, and this is gonna be our full mark. You know where I'm going with this, your gas tank, okay? And I would actually say make those marks that I just gave you a little bit longer so that they stick out, because we're going to make smaller ones yet. So now in between, you make smaller marks like this. Look at that. Looks amazing. Okay. So you make your round dot in the middle, and we're going to have our gauge pointing to that small line right there. And we're going to say that this particular gas tank can take 120 liters. If you're full, you have 120 liters in your tank. Last one. You have a bucket marked off in 0.5 liter increments. Can I do this now? Yeah. Go ahead. If you have a different color, I will ask you to do this. This is a number. There are three ways that you will be presented a measurement or trying to find out. This is a number, a picture, and words. A number, picture, and words. So it's three different presentations of a measuring device. And once you're ready, like I'm making sure you copy this before I go on, because this is important that you follow. Let's do the number first. I'm going to do this for now. Block off the other ones, because I want you to focus on one at a time. Okay? So if I'm giving you this 2¼ inches, if I asked you what is the precision and the uncertainty of this device, a device has been used to come up with this measurement. The precision is, I would assume, based on looking at this number, is the measuring device has a 1/4 mark increment. 1/4 of an inch is my precision there. Right? Because I'm looking at the smallest value here. So this measuring tape is going up by 1/4 inch. It may not be in real life, but that's all I have to go by. So I go by my number, and it's a 1/4 inch. Hey, if you like decimals more, you're welcome to do this. Right? You could have actually written that down to 2¼ inches. That would have been fine. What is the uncertainty? Right next to it, uncertainty is half of the precision. What would be half of a 1/4? This one is tough because this is back to fraction. Anybody? Nope, not half. If you split a 1/4 in half, you actually have an 1/8. Because 2/8, an 1/8 and an 1/8 is 2/8, that's back to a 1/4. So 1/8 is this one is a bit trickier, but what you could have done is this, watch. Or take the 1/4. This is probably what I would suggest most of you do. Write it as a decimal. Let's divide that in half. What are you going to get? Take your calculator and go 0.25 divided by 2. 0.125, right? Do not round. So you either say 1/8 or you say this. Hey, let's see what happens if I go 1 divided by 8. Oh, I also get 0.125, right? So these are consistent. They're both saying the same thing. So based on this number, I have a precision of 1/4 inch, and my uncertainty is half of the precision, right? So that's how I got that. Let's block this off like this. Next, I have a picture. How much am I going up by here? What are my increments? Let's count. So start with me here. So we're going to go 1, 2, 3, 4, 5, 6. It's going up by, to go from empty to full, it's going up by 1/6 of a increment at a time. 1/6 of a liter, right? 1/6 is the increment, but how many liters do I have? 120 liters. So technically, if you split this up into 6, every increment is going up by 20 liters. Because look, 20, 40, 60, 80, 100, 120. So it's 20 liters. And what's my uncertainty? 20 liters divided by 2, which is 10 liters. In this case, my uncertainty is 10 liters. Next, a bucket marked off with in 0.5 liter increments. That's the key there. If you see something that follows marked off, you want to look at that number. So my precision in this case is 0.5 liters. And my uncertainty, once you determine the precision, you just divide that in 2. And you get 0.25 of a liter. So that's your uncertainty and that's your precision. Precision, uncertainty. Precision, uncertainty. Right? You get your uncertainty just by dividing it in half. And if you don't like fractions, turn it into a decimal, no problem. So numbers, picture given, and words. Okay. Next page. It is often necessary to record how much uncertainty exists in a measurement. Unless stated otherwise, there it is again, highlight that. Uncertainty is half of the precision. And we're going to leave that box example, but I want you to do this. Measurement uncertainty can be written as follows. The measured value plus or minus the uncertainty. Box that in. And why do you think it's plus or minus? Because you could be over or under your measurement. Okay? Plus or minus. Because the measurement could be over or under. Out of this, folks, arrows are going to come out of this one. Because if you go with the plus, you will get your max. If you go with the minus, you will get your min, your minimum possible measurement. So the max is the measured value plus uncertainty. The minimum is the measured minus uncertainty. So there's the min and the max. Make sure. So basically you're saying if it's stated like this, that the greatest value you can possibly get would be to take your measurement and add the uncertainty. The minimum would be to take your measured value and subtract the uncertainty. So it should make sense that you would add for the max, you would subtract for the min. Okay? One more here. If it ever asks you for range, you just take your max and you subtract your min. I would just box that in. Now we're going to do some math. A little bit more numbers, not just concepts, right? So let's talk about it. We talked about accuracy, then we start talking about precision and uncertainty. And precision and uncertainty go hand in hand. You get your uncertainty by taking half the precision. Okay. We will say state the precision and uncertainty of the following measurements. Okay. I will do A right up here because I have room. Precision, and then I will figure out my uncertainty later on. What is this? Out of number, picture, and words, what would this be? Picture, right? So we go by the picture, and you look at what's the increments, how much is this going up by? What does each line here represent? You've all used a ruler before. What would it be? Millimeters, centimeters? So these ones, this would be 1 centimeter, 2 centimeter, 3, but that's not the smallest increment, is it? They're way smaller lines. What are each one of these ones called? Millimeters, yes. So we go 1 millimeter. It's the smallest increment, right? Smallest marking. That's what I will say. This is basically saying there's a ruler marked off in millimeters, right? And so it's 1 millimeter. So uncertainty will be 1 millimeter divided by 2, which is 0.5 millimeters. That's it. You stated the precision and uncertainty of this device here. If I asked you to state the measurement plus or minus uncertainty, what is the actual measurement of this pencil? If I were to go, what would you say that would be in millimeters? That's 62, right? 62 millimeters. Plus or minus, uncertainty is 0.5. You could have stated this in centimeters, like the actual measurement, 6.2. Just make sure you go centimeters then. And they would have different units, right? Okay, B. An odometer records distance traveled to the nearest kilometer. This is words, right? I'm giving you a scenario in words. What would your precision be in this case? Because you need your precision before your uncertainty. What's your precision here? Wakey, wakey. What's your precision? It says it right here. It's not a trick question. It's to the nearest kilometer. That's what this odometer reads. So that's your smallest, right? Smallest increment. We are assuming, right, that it can only go up 1 kilometer at a time. So 1 kilometer, right? Uncertainty is 1 kilometer divided by 2, which is 0.5 kilometers. I will do this arrow from here all the way down to where I got my, and then from the precision I can easily get my uncertainty, right? No problem. I just need to divide it by 2. C. The outside temperature was recorded as, oh thank goodness there's a number. The students always want a number. So this is a number scenario where it's 12.5 degrees Celsius. What is my precision here? 0.5? It's not 12.5, but you're close. If it lies in here, Angelica, it lies in here. If it says it like this, what can we assume? If it got just a little bit warmer, what would our next number be? 12.6, right? Wouldn't it? And then 12.7, 12.6. So our precision, this thing is precise to 0.1 of a degree Celsius. Does that make sense? I think practice is what's going to make sense of it. Not right now, you might be like, what? But it's because of this. Don't copy down the 0.5. This is, listen carefully. If this question had said this thermometer has markings of 0.5, absolutely, then your precision is 0.5. But it doesn't say that. It's just a number. So you have to look at this and at that, right? So this is telling you that it's going up by 0.1. What's my uncertainty? 0.1 degrees Celsius divided by 2. You can do this. I believe in you guys. What's 0.1 divided by 2? Use your calculator if you're not sure, but it's going to be this. Okay, it's going to be half of your precision. So this is my uncertainty. And this is the precision. Last one, D. What is this scenario? If you're given a number, it's a number. Okay, like if there's a number in that text and it doesn't say anything about markings whatsoever, so it's a number. So we're going to go 5.25 hours. Let's see if you can do this. I have a feeling that. What would be my precision here? If you had to guess. What's that? Minutes? We have to go by the number. Let's put it this way. If it took a little bit longer, what would be a number above this? Wouldn't you say? This thing that's measuring could go up to 5.26, wouldn't it? What if it took a little bit less? So what is my precision there? How much am I going up by? What is possible to go up by? 0.01. 0.01 of an hour. And it's all here. You count how many decimals. Let's say this had 3 decimals. You would go 0.001. Like you put the 1 in place for that last decimal that this thing has, right? And so what's my uncertainty? 0.01 of an hour divided by 2. Try this on your calculator. You do not round here. Oh my goodness, right? What are you teaching me, Mr. Dirksen? Why don't you skip this one? If I could, I would. Question here. I hope you're still awake. Which one of all of these here? Shouldn't know, maybe not. I'll wait. Maybe between A and B. Between A and B, which one is more precise? They both have a 1, but which one is more precise? A is more. And here's the reason why. Go back to Back to 82, a measurement marked in millimeters would be more precise than a ruler marked in centimeters. So the smaller your precision, the smaller the unit, the more precise you are. Okay. Okay, let's see here. Let's put it to the test. Just do 9 to 11 for now. Take a couple minutes, 9, 10, 11. You're supposed to have a precision and an uncertainty for all of these. There is a number, not just words. There is a number. Go ahead. I'm not going to take too long. Okay. So yeah, I was talking to quite a few of you already, but this is important. If you see the markings This trumps everything else you might see. That right away says that precision is to the nearest 1 centimeter, and uncertainty is 1, don't forget your units, it's 0.5 of a centimeter, half of a centimeter. The next one, it says an odometer. So this would be words, by the way. Words are given, there's no number, okay? Odometer is to nearest 1/10 of a kilometer. Words, okay? So precision, if you know anything about 1/10 of a kilometer, it would be, right? It's 1/10, 100th, and so forth. Uncertainty is 0.1 divided by 2, which is 0.05. Don't forget your units, okay? Grab a seat. Okay, if you have a nurse, there's actually a number. Thank goodness, right? So when it's a number, go to the last decimal in this case, and just, it's to the nearest 1/10 of a degree Celsius. Uncertainty is just half of that, which you can just go off of the previous one, and there's your uncertainty, there's your precision. Okay, so you can get it by just looking at the text or by just looking at the number. But keep this in mind. If you ever have a number and let's say you had a thermometer like this, right? You would look at the markings on this device that always trumps the actual number. So you got to look at the markings on that thing to know for sure. Okay. 12, I'll do it with you, and then I'll get you to work on some questions on your own because I wanted you to have a little bit of practice before. Determine the precision and uncertainty of this measuring device. This is in inches. By the way, write that down. What is my precision in this particular case? This is the trick. You look between 0 and 1. I'm just going to focus on that. Count. 1, 2, 3, 4, 5, 6, 7, 8. So this device is able to measure down to 1/8 of an inch. Okay? Angelica, are you writing this down? Okay. 1/8 of an inch is my precision. If you don't like fractions, you divide that and you get this. I will honor that. That's fine. And my uncertainty is, who can tell me what the uncertainty is as a fraction? If it's 1/8, then it will be 1/16. Okay, you double the denominator, 1/16, okay, of an inch. Or if you want to divide that by 2, right, 0.125 divided by 2, look at that. Do not round, 0.0625. As long as you're not rounding, you're fine, okay? And state the measure of the string with its uncertainty. So if you measured this thing, what would you say if all you had was on the ruler? It's right here. What would you say? What would you write down? 1 inch and would you say 2/8 or 1/8? Which one is it closer to? It's closer to the 2, so you have to go with it. 2/8 of an inch plus or minus my uncertainty. I'm going to go 1/16 inches. Somebody's probably saying, Mr. Dirksen, 2/8 is what? 2/8 is really a quarter. Not going to sweat that. Okay, I'm not going to make a big deal out of that. But I'm sure that if you were in Woods, your teacher would probably not be happy with you saying 2/8. They would want to hear a quarter, right? But there it is. We're going to leave the other ones for now. Okay. I want you to take the worksheets, the worksheet package. And I want you to go to page 3. Page 3 to 4. Page 3 to 4 in the worksheet booklet. So take that worksheet booklet and try to do as many questions as you can. Go ahead. Knowing what you know so far. Go ahead. Young class, okay? Right. Well, it would be an appropriate scale for revision, right? Oh, so it's not, it would be appropriate scale, but not a solid unit, but not that. So wait, this is the scale. Scale is good. If you use your thumb, probably not good. So then just make a conclusion not accurate. Because one of these scales is not accurate. They both have to pass in order for you to say that. So use a teaspoon, so this is standard. Standard. Seems to be good skill. Yeah. So the good part is good skill. So this one is out. Yeah, so this one would be more precise. Keep working. I'm just going to add something to this page here on page 4. I'm just going to show you the first one. So if you're not there yet, I would encourage you to go to page 4 once. So if it's just 5 centimeters, your precision is 1 centimeter. Your uncertainty is 1 centimeter divided by 2, which is 0.5 centimeters. Pay attention to this part. It says the measurement, like you're supposed to state your measurement with the uncertainty. So you go 5 centimeters, which is the original measurement, and then you just go plus or minus the uncertainty you will have calculated, right? So measurement plus or minus uncertainty. So you find the precision, you find the uncertainty, then state it, right? The measurement plus or minus its uncertainty. So this is really what this column is asking for.